Okay, so we're going to find these two derivatives using the definition of a derivative. So the definition of a derivative is written up there. I'm going to do the limit as x approach, not as x, h approaches 0 of f of x plus h. That's square root of x plus h plus 2 minus f of x. That's x plus 2, square root of x plus 2 all over h. Now there's a trick to this because I can't do anything inside the square roots. So I shall rationalize the numerator. Reverse of what you've done before. But I'm going to do this because it's going to give me something beautiful. To rationalize the numerator, I am multiplying by the conjugate of the numerator, giving me on top. When I multiply by conjugates, I essentially square the two parts. And squaring the two parts means I can distribute that negative and essentially drop the parentheses, which allows me this beautiful thing where x and negative x cancel and 2 and negative 2 cancel, leaving me with just h. The limit does carry down, I just don't want to write it. It's plus h plus 2. Clean this up a little bit. X plus h plus 2 is the 2. And those h's will cancel. Now, this is where it gets nice. Limit as h approaches 0 of the h on top and bottom are gone. As h goes to 0, my first square root becomes just square root of x plus 2. And since those are both the same, I can add them together and get 2 square root of x plus 2, and I simply get that. Okay, let's do problem 2 here. G of x, limit as h approaches 0 of 1 over x plus h minus 4 minus f of x, 1 over x minus 4, all over h. The first thing I need to do is get a common denominator in the numerator. So I'm going to multiply top and bottom by the other one. And this would be really gnarly not fun if I tried to FOIL that out, but I'm not going to FOIL it out. And I wrote the denominators in the same order. I'm going to go ahead and, oops, I should probably write the all over h part. I'm going to go ahead and distribute this minus to everything, which plus 4 and minus 4, those are a common denominator, so they go together, and minus x and x cancel, leaving me with negative h over and this divided by h is the same as times 1 over h, which means my h's cancel. The key to definition of a derivative. And we have limit as h approaches 0 of 1 over x plus h minus 4, x minus 4. I plug in 0 for h and I get 1 over x minus 4, 1 over x minus, or 1 over x minus 4 times x minus 4, or 1 over x minus 4. Oops, I lost a negative. There's a negative there. Negative 1 over x minus 4 squared. And those are kind of two of your hardest definition of derivatives you will need to know how to do.